Hello guys, this is a continuation of chapter 2, exactly where we left off on Wednesday's class. Okay, so we're covering the factors, how time and interest affect money. Okay, we saw the single payment factors, which are P's and F's, how to convert or to find one given the other. Okay, I showed you how to use the tables. And we also have the uniform series factors, which involve A's, okay, which are equal amounts, okay, or the same amount in consecutive interest periods or years. Okay, so you learn how to find P given A, vice versa, and also when you have F's, find F given A, and vice versa. Okay, now, well, the A, we said that it's the same amount every year. Now, what happens when that amount varies? Okay, so we're gonna be covering gradient formulas. What is a gradient? An arithmetic gradient, okay, it's when you have an amount that increases or decreases by the same amount. For example, here you have 3 periods, or let's say 3 years. You start off with $800, then it goes up to $900, and then increases to in year 3 to $1,000. Okay, so notice that from here to here, you see an increase of $100. And from here to here, you see another increase of $100. This is your gradient, your $100. Okay, now you have also a factor formula for the gradients. If you go to your table, okay, you're gonna see that the 2 last columns are for our arithmetic gradients. Okay, so you're gonna be using these 2 columns for this. Okay, now, what says that it's for the gradient only? What does that mean? Okay, so, well, first of all, it says that it starts at a base amount and increases by constant gradient g in years 2 through n. So you have your present, your P, then remember I said that the A starts in year 1, but your gradient, it's not going to start until year 2. This is why, if you go back to your table, you're going to see that there is no amount or no factor in year 1 because it doesn't start until year 2. Okay, so that's why they're empty. Okay, so notice that here, okay, so this is your base amount, or your A. It's going to fit into all the gradient amounts that you have. Okay, so for example, if we go back to this one, you have 800 in year 1. In year 2, you're going to have the same 800 plus the gradient. And in the 3rd year, you're going to have the 800 plus the gradient times 2. So this will be your A, or your base amount. Now, if you want to to find the equivalent value for the entire thing, you have to break it down into 2 parts. The base, or your A, which is the red, and your gradient, which is the black part, the black arrows. Okay, so you have to use both factors here. Find P given A and find P given G, and add them together. So that would be the total P, will be the base and the gradient. Okay, now, well, this gradient, it's increasing downward. Why? Because it may be like an increasing cost or an increasing expenditure. Now, okay, so again, going back to the formulas, this is the one that I showed you for the gradient only. This is when you want to convert to P. Now, you can also convert to A by using this formula or this factor, but again, it's for the gradient only. Okay, so if you want to convert the whole thing to A, you would also need to add the base to this one. Okay, so we have a diagram, an example here. So it says that the estimated annual revenue is $5,000. Okay, so notice that now your gradient, it's still increasing, but it's increasing upward. Okay, so it starts off with a 5,000, and then this is your keyword to identify gradients, increasing by. Okay, so it's increasing by $500 per year, starting 1 year after your A. Okay, so starting in year 2. And then with the 8-year period at 10%. Now, for this chapter at least, just focus on increasing gradients. Okay, so they can either increase, like they go up, Okay, either with positive cash flows or like we previously saw a negative cash flow, but the gradient was still increasing. Okay, so just for now. Let's go over example 2.7 so that you can get a better picture of how this works. Okay, so example 2.7 reads, the highway department expects the cost of maintenance for a piece of heavy construction equipment to be $5,000 in year 1, to be $5,500 in year 2, and to increase annually by $500 through year 10. At an interest rate of 10% per year, determine the present worth of 10 years of maintenance costs. Okay, so we start off like we would start any other problem. Identify what we have. Okay, so it says right here that, okay, the cost in year 1, it's $5,000. Okay, so that would be what? Okay, so it's in year 1. So notice here that we have year 1 here. So let's circle year 1. Okay, so if it starts in year 1, that means that it's what? An A. So you're gonna have an A of $5,000. Please excuse my handwriting. It's difficult. Okay, now you have 5,500 in year 2. But then you're not gonna be actually using this number because then it says that increases annually. Okay, so let's underline increase annually by 500 through year 10. So this is just a demonstration that it's increasing by 500. So your 500, it's going to be your gradient. Okay, through year 10. So that means that you have an N of 10 years. Okay, at an interest rate of 10% per year. So that means that your interest is 10% per year. Okay, what are we looking for? It says determine the present worth of 10 years of maintenance costs. So that means that our unknown is P. Okay, what is the formula for the gradient? So we said it's divided into 2 parts. So the total P is going to be equal to the present worth of what? First of all, the base amount. Of the base amount. How are we going to find this? Find P given A. Now to this, you're going to add the present worth of the gradient. And how are you going to find this? By using the find P given G factor. Okay, so just let me underline, okay, that this is the base amount and you're going to have to add the gradient. Okay, so what's next? Let me pull it down a little bit. Okay, so well, let's plug in the values here. Let's write the formula and then plug in the values. Okay, so if you want to put it in the complete formula, it's going to be P equal to 5,000. My factor is find P given A at 10% interest and 10 years plus the gradient, which is 500, find P given G 10% and 10 years as well. Okay, so let me just make a note here that this part right here and this part right here, okay, so this one will be your base amount and this one will be your gradient. Okay, Now, let's solve for this one. So if you go to your tables, you're gonna have 5,000, and the factor in the table is 6.1446, and let's add the gradient, which is 500 times 22.8913. Okay, which gives you a total of 42,169. And this will be your answer. Okay? Now, if you were to draw the diagram for the gradient, like I didn't start off by drawing the diagram, okay, but it would look something like this. Now, I'm not going to put the 10 years, okay? So I'm just going to draw a fraction of it. So let's say, hopefully I'll get a straight line. So let's draw 4 years only. Okay, close enough. Okay, so you have year 0, 1, 2, 3, 4. Let's assume that it keeps on going. So I have year 0, 1, 2, 3, and 4. Okay, so in year 0, we have the P that we are looking for. Then, okay, so let me go up a little bit. It's the cost of maintenance. So therefore, in year 1, okay, you're gonna put negative cash flows, but again, it's increasing. Okay. So why isn't it drawing? Okay, like that. And something like that. Okay, notice that this goes up to year 4. Okay, so here, you're going to have 5,000. Here you're going to have 5,500. Here you're going to have 6,000. Here you're going to have 6,500, and so forth until you reach year 10. So this is what your gradient will look like. Okay, and your A will be somewhere in here. Okay, so this will be your A, and you're gonna have it every year. Okay, so this is what the diagram will look like, more or less. Okay, I'll scan a prettier one to your notes. Okay, so now this is using the P formula. Now remember, in this example, it mentioned that you can also convert to A. So we use this factor right here. How would you use this one? Okay. So this is not part of your problem here. It's not asking you to do that. But let's add like a second part to it. Okay, so now let's find the annual worth. Annual worth. Okay, so that means that we are now looking for the total A. Okay, so remember also the formula, we have to break it down into two parts, the base and the gradient. Okay, so my total A, it's going to be equal to the base amount Okay, now what do we do with the base amount? Okay, so here on top, we were finding P given A. Now, what is the base amount? We said that the base amount, let me go back to the presentation, it's already an A. So what do you think that you're gonna do to the base amount if you're trying to convert to A? Again, here you're converting to P, so it's find P given A. So here, it's not like you're going to put find A given A. It's already in A. So all you have to do here is keep the same number that you have. So you're just going to add it. Okay, you're not going to do anything to this. You don't need any factors for A. And then to this, you're going to add the annual worth Of what? Of the gradient. Meaning that you're going to find A given G. Okay, so if we solve for this, the base amount we said is 5,000, and you're going to add the 500, find A given G, 10%, and 10 years. Okay, so if we solve for this, it's going to be 5,000 plus 500, and then the factor is going to be 3.7255, which is going to give you a total of 6,862.75. Now, since this is an A, this is going to be per year. And this right here, it's going to be your answer. Now, what does this look like? Okay, so let's say, let me draw the diagram. So you would have something like this again, so this is part of the problem, but what does this answer mean? Okay, so here we converted everything to P, right? Now, but here, converting to A means that you have your diagram, like you have your gradient like this. Okay, and you're going to, let me put it here. The equivalent annual worth would look something like this. You have your year 0, so that means that you want to know how would it look like in the A form. Like, even though you have your base over here, like if you were to distribute the entire, like the gradient part into equal or uniform payments per year. That's what this means. That's what you do when you find the annual worth. Okay, guys? So, well, this is the end of this section, okay, for gradients. Please, if you have any questions, you can record or like just save the minute where you had the question, or take a screenshot and email me, okay, and then I'll reply to you as soon as I can. Okay, so this is the end of example 2.7 and gradients.